very much for coming to this inaugural Water and Climate Justice Conference, and thank you all for your wonderful hospitality. The first session, we'll be talking about water, climate, and inclusive economic growth, and we will have three brilliant panelists, many of whom who will be known to all of you. Our first speaker is going to be Dr. Abid Burki, a professor emeritus here at LUMS, who served as professor until 2021. He held numerous academic and administrative roles, including founding graduate program director of economics and director of the Center for Management and Economic Research. He has consulted for both government and international government and NGOs in a number of areas and has published over 50 papers and reports. Today he'll be talking about the effects of extreme temperature and rainfall on staple crop yield in Punjab, Pakistan. So thank you for that. Our second speaker, Dr. Sanval Nasim, currently an assistant professor at Colby College, but also an assistant professor here at LUMS as well. He received his PhD in environmental and natural resource economics and policy at University of California, Riverside in 2015. And the focus of your research is on citizen responses to environmental degradation. And he will be speaking about managing Pakistan's groundwater. And our third speaker today, again, will be known to you, Dr. Hadia Majid, Associate Professor and Chair of the Economics Department here, consultant to governments, NGOs, and numerous governmental agencies, particularly around the issue of gendered labor market outcomes. She received her PhD from Ohio State University, and today she will be speaking about public goods, climate change, and livelihood diversification. So I thought that each of the speakers would speak for about 20 minutes, I believe, and then we'd have ample time for questions. And obviously, this is an economics-focused panel, but I thought we could also dovetail it with the themes raised from our keynote address, which is thinking about how, in the face of acute urgency and acute urgent need, how do we also get through institutional barriers to necessary economic policies and reforms? But I leave the questions also to your imagination. Thank you so much.
My focus of presentation today is on a very sort of narrow area of, let's say, the impact of climate change on let's say, agricultural production, especially the crop sector. And there are 5 sort of major staple crops in Pakistan, as we know, that, for example, wheat is grown almost by all the farmers, and most of them are very small farmers who hold perhaps less than 5 acres of land. And naturally, if there is a change in their production prospects over time, so they will impact their livelihood, and also it will impact the inclusive growth. Similarly, we also have some cash crops like rice, and rice is also one of the major crops, and sugarcane and cotton. So these are 2 more crops which are also related to 2 major industries in Pakistan, sugar industry and the cotton and textile industry. So with this background, what I'll try to do today is to share with you, this is a work in progress, so there are some findings which are original in the sense that they are based on very large data, actual data of farms in Punjab, Pakistan. And this data is collected by the government of Punjab, Agriculture Department, and it's regularly collected. And this data has rarely been used for such an analysis. So my focus is more on this data, and I'll be using, let's say, the data, because I think when we talk about climate change, so normally we expect that we have a longer sort of time so that we are able to measure any sort of impact of climate change. So I will be using this data. Let me just share some of the key highlights that I have. I think the first important point that I want to highlight is that I'm using a plot level data plot level means that there is a measurement of a particular size by the government officials, and they just take output and input for that particular area. So this is, I think, something which is rarely done, because that leads to a lot of, let's say, measurement error in production and also the area. So I think that's one important highlight. Secondly, I will show that if we take the four staple crops like wheat, rice, sugarcane, and cotton, so if you take the actual climate data, which is spatial data across all the regions that I have taken, let's say there are 36 districts, so you have different climate. So how does the average sort of climate or average temperature, maximum, minimum temperature, wind, speed, and also moisture and other things, how do they affect the yield? So that's another important thing that I'll be talking about. And my sort of main contribution relates to the impact on wheat yield if you take the phases of, let's say, growth, crop development, because crop is grown, let's say, for about 150 days, and there are different phases in this crop development, and temperatures affect differently in these phases. So I'll just classify, let's say, wheat crop into four categories, four seasons or four phases, and then see that how temperature and rainfall, they affect differently in different phases. So that's another important thing that I'll be talking about, and I think its implication on policy. Now, there is a lot of research already that talks about the crop yield and sensitivity. However, most of this research ignores the fact that the crops are affected by temperature and rainfall in different growing cycles, so different phases of crop growth. So this paper actually takes different phases of crop growth and tries to see that how temperatures affect differently in different phases. So there are two levels of analysis that I will be doing. Firstly, I'll take the spatial variation, which is actually district level temperatures and rainfall, and taking the average for the whole period. For example, if there is a 150 days crop, so I'll take the average temperature, maximum temperature for the entire period. So there is one value that I'll be taking. So I'm taking maximum temperature, average, and minimum average temperature. Similarly, rainfall and other variables. That's one type of analysis. The other type of analysis is that rather than taking the average, if we classify this, let's say, crop development into phases. So if, let's say, we define those phases, so how this temperature and rainfall affect differently in different phases and in different regions. So it's not simply the analysis that is, let's say, for the whole of Punjab, but I'm also focusing on the 5 agroclimatic zones that Pakistan, Punjab province is commonly divided into. So like rice wheat region, we know that, but there are particular districts that are classified into it. We also have mixed cropping region, we have cotton wheat region, low intensity Barani and Barani area. These are 5 regions that I will also be focusing on. Now the data, as I said, is a plot level data. It's a measurement of, let's say, I think it's 300 sort of feet area, that there is a cutting of 300 feet. They go to they sample, I think they have done sampling of, let's say, about all the union councils in Punjab, and from all those union councils they have taken one sample. So there are 5,500 union councils in Punjab, and they have taken data from all 55 union councils. So they typically take 3 farmers in a village, and each farmer has 2 plots. So when I am talking about a plot, so this plot basically belongs to a farmer who has 2 plots. So in a village, there are 6 plots in a village. So this is the data that I have taken. There are roughly about 5,000 to 6,000 observations in a particular year. So I have data from 2013 to 2020 for 4 crops, and for wheat, that the second part of the analysis will use the data from 2013 to 2019. So I have taken this data from the government of Punjab, and I have combined this with the weather data, which is publicly available from different sites. And this weather data is a daily degree days data from which we calculate the growing degree days, which are commonly used in climatology and in agronomy. I think these are commonly known concepts. One is called the growing degree day. Growing degree day basically is the temperature which is in the optimal range. For example, for wheat, it's about 5 degrees to 25 degrees. So temperature, if it remains within it, so it's the sum of all the days, and that is taken as one of the variables. Then I think the extreme temperature is referred to as killing degree days. So any temperature that is more than 25 degrees during the growth cycle, so that is also summed up. So that's another variable that I've taken. And similarly, the rainfall, that is the daily millimeter rainfall, so that's summed up. So overall and also for different phases. So this is, I think, the data. And I have actually done 2 types of analysis. It's an econometric analysis. I know that many people may not be very comfortable with that, so I'll just skip some of these things. So generally, I think what we expect is that the crop yield is closely linked with climate variable. So one top type of analysis takes the maximum and the minimum temperature because they impact the yield indifferently. Like, I think it increases the photosynthesis that helps in enhancing crop yield, and heat stress impacts the plant growth by creating sort of imbalances due to protein instability and cell reaction. And higher temperature generally lead to desiccation or let's say excessive growth of the plant, and that affects yield. I'll also talk about these aspects in a minute. And appropriate humidity and wind is essential for balanced growth of plants. So using, I think this model, I've calculated the elasticities of yield with 5 different weather variables, and this analysis is based on, let's say, 4 crops. I've taken wheat, rice, sugarcane, and cotton crops. Now, if we look at the general pattern, so this is the weather data, and for 2013 to 2020, this is average maximum temperature, and these are 4 crops. This is for average minimum temperature, average humidity, wind speed, and average rainfall. So you see that there is a lot of variation in the temperature. Let's say if we talk about wheat, so there is an increase in average temperature during this period. So average temperatures have varied from, let's say, about 22 degrees to perhaps more than 25 degrees. So there are also similar variation for other crops, and there are some sort of crops which have been affected more. For example, here humidity has varied more than other things. Similarly, about the average temperature. So this is the kind of variation that I have used, and sort of these are my first set of results, which try to relate maximum, minimum temperature, and rainfall and humidity and wind speed. So the stars here indicate that these are statistically sort of important impact. So what we see here is that maximum temperatures negatively affect wheat, sugarcane, these two crops are affected. An increase in minimum temperature, they affect wheat, rice. I think the most effect is on rice, and there is a positive impact on sugarcane and also on cotton. So naturally, that's what we expect, that when minimum temperatures increase, so cotton benefits, and sugarcane is also a year-long crop, so that also has a positive impact. Rainfall consistently has negative impact on wheat and rice crop, and also on cotton crop. So similarly about the humidity, wind speed, it's not as important, but I think for sugarcane it's very important because after the rain, if there is a strong wind, so I think there is a huge loss for the sugarcane crop. And same happens about other crops when they are in the maturity phase. So I think these are sort of the results, and I've summarized these results here. That low temperatures support higher yield, but higher rainfall during maturity damages wheat crop. Then basmati rice, also a 1% rise in minimum temperature lowers yield by about 0.72%. And similarly, the annual yield grow, and I think there is a time trend that I've used which indicates that overall yield has remained constant for some crops and has increased for the other. Similarly, for sugarcane, that sugarcane yield increases by 3.3% annually, and heat stress lowers yield, while higher minimum temperature and rainfall they boost yield. So cotton benefits modestly from high minimum temperature, but increased rainfall and humidity they significantly lower yield. So that's the first part of the analysis. And secondly, I've taken a large sort of data, about 39,000 farmers. Actually, these are the plots, so there are 2 plots per farmer. So this is 7 years data, and this is augmented by the meteorological data. And there are like phases I just explained earlier. This is the growing degree days, which is a positive temperature. KDD is the negative sort of temperature, which are more than what is required. So, and when there is more accumulation of such temperature, so that negatively affects it. Now, these are the biological stages. There are about 10 stages for wheat crop growth. It's about 150, 160, 60 days sort of overall crop growing cycle. Normally, crop is grown roughly, let's say, from November till April. So that's the time frame. This is called a Rabi crop, which is a winter crop. So there are Rabi and Kharif crop. Kharif crop is mostly the summer crops. So we don't expect very sort of high temperature, especially during the first 3 months of the crop, like November, December, January. And we don't get a lot of temperature during that time. But I think due to the climate change, as we have noticed also, that there are phases, there are times when there are very high temperatures which exceed 25 degrees during the month of, let's say, February. I think that's one of the sort of areas which is a matter of concern. Because if there are high temperatures, let's say in April, so they are beneficial because that's where the wheat crop actually needs more temperature so that there is desiccation and the crop becomes ready for harvesting. So these are, I think, 10 phases are classified into, reduced to 4 main phases. It's called sowing to tillering phase. This is a 68-day sort of phase from sowing till, I think, the first leaf, and so that's the first, I think, phase, which generally we don't get a lot of temperature during this phase because, okay. So that's the shooting phase. This is the vegetative phase where after germination of the seed, so then it tends to actually grow and then moves on to the heading and flowering phase. when the crop becomes ready for seed formation, and then there is seed formation and maturity. So roughly 68 days for first, then you have 26 days for second, 30 days for the third, and 27 days for the fourth stage. So these are four stages that I have taken. And these are the growing degree days. As you could see, that average is 1730, and there is a lot of variation across regions. We have right wheat region. The highest temperatures are in cotton wheat region, which is in South Punjab. So we have like Multan, Bahawalpur, Rainiyar Khan, Riji Khan, and all these areas, they get more sort of heat. Similarly, they also have higher sort of killing degree days, the heat units which are more than the optimal. So they are also highest there. The lowest temperatures, as you could see, are in Barani area, because this is Jhelum, Rawalpindi, and those areas. That's in the north. So naturally, they have lower temperature. So how does this sort of temperature, and similarly, there is also variation in rainfall. Now, this is generally just like to explain that the last three phases, this is, I think, the overall entire season, 150 days, and this is for four phases. And because the first phase has 68 days, it has more values. And then I think for the last three phases, roughly they are equal. So as you could see that there is a huge increase in temperature, both growing degree days and killing degree days. It's also interesting that the killing degree days values are zero for many, at least 4 of the 7 years. And for several districts, they are zero. So which means that this excess temperature is relevant only in stage 3 and stage 4, because first two stages are not as important. This is my overall data. I have actually controlled for about 17 form level of facts, other than my sort of variable, like yield, for example, is 1403, which is roughly about 35 mounds per acre. So 35 mounds per acre. And based on that, if I just focus on the results, so I think my results indicate that increase in, let's say, growing degree days has a negative impact, which means that perhaps there is a suggestion that farms which are using hybrid like short varieties, they have, so it means that lower GDD increases yield. It means that if you have a smaller or short duration varieties, because there are about 20-25 different varieties, so the ones which are short duration, they lead to more output or more yield. But killing degree days, as was expected, it has a negative sign, and rainfall also has a negative sign. Now, I'll just skip that. There are two more points that I want to highlight. Firstly, if we want to classify that which period is the worst for crop growth, so I think this is done in this graph, where I have actually seen the slope. As you could see, the slope is higher and this is lower, and the coefficient of variation is also higher, which indicates that this is the heading and flowering or third phase in crop growth, particularly the time period from 15th February to 15th March. I think this is the time when there is if there is the increase in temperature more than 25 degrees, so that has the highest sort of negative effect. The second important effect is the maturity phase, that's the last phase, that is from 15th of, let's say, March to 15th of April. That's the first point that I want to highlight. Secondly, I think the growing degree days also has the highest effect in phase 3. That is again heading and flowering stage, which was also the case for the KDD. Now, in terms of rainfall, I think again it is the heading and flowering which has the highest effect. So this is the phase when there is the I think the most negative effect on crop growth, and this is due to the sort of changes in climate. Finally, I think I've also seen that if, let's say, there is a negative impact, so are there any adaptation measures being taken? So I have actually calculated that. So I have actually regressed the length of growing season or growing cycle with the temperatures. And I have found out that in terms of, because of GDD increase, there is about 0.08 days per GDD decline in the crop cycle. And for KDD, there is about 0.18 or 19 days per increase in GDD that there is a decline, like decrease in the crop cycle. For example, farmers are adopting to varieties which are short maturity varieties. Instead of 160 days, they are adopting to like varieties which are maturing in 135 days or so. And similarly, I think here, if I see by crop region, so I notice that the highest effect of KDD is found in rice, wheat, and mixed cropping region, and also the Barani region. And for GDD, I think it is in rice, wheat, and cotton, wheat, and mixed cropping region. What it means is that farmers are conscious of the rising temperatures, and over time they have learned from I think their operations, their losses, and they have started adapting to the varieties which actually are short maturity varieties, and this is happening more rapidly in areas where temperatures are high, like rice wheat region and mixed region. And I think that is where most of the wheat crop is grown in Pakistan. Naturally, it has its implication, and if it happens, a decline in staple crop, as I said, 85% of the wheat farmers are, let's say, less than 10 acres. So that will have a negative impact that they'll decrease their farmer income, it will increase poverty, inequality, and also lead to like higher food prices. Actually, if there is a crisis in staple crop production, so nutritional status is also, it becomes vulnerable for I think climate change, and naturally there are some mitigating measures. I'll talk about that here. Thank you very much.
Thank you so much for having me. Those of you who know my work, I predominantly work on air pollution these days, but I used to work on water. My grad school days, my research focused on groundwater in Pakistan. And then I sort of continued doing that work as an early researcher when I joined LUMS back in 2016. So recently I wrote this chapter for a book on Pakistan's water policy. The book was on Pakistan's water policy, but my chapter specifically kind of distilled a lot of my thoughts on how groundwater in Pakistan is managed and what are the sort of typical regulatory and market failures that we've observed here. And I offer some form of institutional measures or responses or policy instruments that we can leverage to kind of counter how we manage the resource in the country. So my presentation today kind of focuses broadly on these thoughts that I have synthesized in that chapter. Okay, a brief history and just sort of contextualizing the problem. Groundwater for a fairly long time was perhaps not an issue in the region, or over-extraction of groundwater wasn't perhaps a issue in the region. But that was because there was sufficient canal water, surface water that the country had or the region had for irrigation. So this sort of graph here shows you the historic water table levels in the Punjab And what you see is that it was mainly after colonial era investments in irrigation infrastructure when water tables in the region started rising. So before those sort of investments in canal infrastructure and in barrages, etc., the water table level was fairly low. But once we had that infrastructure and those investments, through depercolation, through seepage of water in our canal infrastructure, the water table level fairly basically started rising in this in this basin. So what happened post partition after in the sort of post colonial period is that the government specifically in the UB era, there was again massive investments in the existing colonial infrastructure that we had inherited. Quite a bit of we ended up investing in new dams. Mangla is one of them. We started revamping the barrages that were developed in the early 20th century, and perhaps added more secondary and tertiary canals to the existing infrastructure. But as a result, the water table level at this point started rising dramatically. And in fact, many parts of the Indus Basin became waterlogged. So because there was just too much seepage of water, the water within the system into the aquifer, the water table level basically shot up tremendously. The way to counter that at that time was that the government started subsidizing what at that time were called the SCOP tube wells. So this was a public-led program where farmers were given tube wells to actually draw down the water table level. So instead of relying on surface water irrigation, a lot of farmers started using these publicly funded tube wells for their irrigation needs. And over time, farmers started installing their own tube wells as well, because they just basically realized, because the water table level was just so high, that the costs of extracting that water weren't necessarily very high compared to what they actually had to pay for surface water. And so this became like a very easy resource or a natural resource to kind of access for irrigation purposes. So over time, over the decades, as you can see, the number of tube wells in the region, this includes tube wells in the Punjab, and in Sindh, the number of tube wells started rising almost exponentially. And it wasn't just the number of tube wells, it was also the cultivated area, because now that you had access to groundwater, along with surface water, the area under cultivation went up as well. So you could bring in new fallow land into cultivation. This graph effectively shows that the area under groundwater cultivation increased as a result of so it was not just the number of tube wells that went up, but it was also the area under irrigation. So where do things stand? Well, because of the influx of the number of tube wells and then the area under cultivation and increase in crop production, over time, what became was a repository of water and this reservoir of natural irrigation water, that resource started depleting pretty fast. So because the number of tube wells went up, because the area under groundwater cultivation and irrigation increased, the water table level started falling by the 80s. So this is a graph, I think, taken from a report by the government of Punjab, and it effectively shows that, so the red areas are areas where water table levels are dramatically low. And if you notice that often there's a lot of heterogeneity, spatial heterogeneity in water table levels, and that is because water table levels tend to actually go down considerably in in the lower reaches of rivers and canals, versus the sort of the head of water courses or rivers. So in the tail ends of water courses, the water table levels have gone down dramatically versus sort of like the head end of water courses and rivers. But that is not to say that like spatially like everything is okay at the upper ends of the rivers and water courses. Even there, in many parts, in the Rachna Doab and the Bari Doab, which are our most productive kind of like regions in the Indus Basin, the water table levels across the board tend to be pretty low. So why does this happen? Like, why do we in my earlier comments, I kind of mentioned that this is a function of like regulatory and sort of market failures. But why do we observe this kind of dramatic fall in water table levels? And that effectively has to do with the fact that we treat groundwater. It's a classic case of an open access resource. Which is, I mean, I'm going to be, so the two kind of like technical terms that we use is the resource itself is what we call rival, and it is non-excludable. So a rival good is effectively like any other private good that you consume, that if you consume a certain amount of that good, there's less left for others. So if you consume a certain amount of groundwater, there's less left for others to consume, but it's non-excludable under the current institutional arrangement because you can't stop people from accessing groundwater. As long as you can install a pump and put that on your field, you can take that resource out of the ground and there's no one to stop you, right? Unlike private goods where there's a market and a price that prevents you if you, the market and the price prevents you from consuming too much of the resource. So under an open access regime, and I don't want to use the word myopic in like a pejorative sense, but effectively, given the large number of farmers in the region, we can think of their behavior as myopic because they're kind of focusing on short-term gains because they know that if they were to leave the groundwater for like future consumption, so sort of saving the resource of future consumption, somebody else might come and kind of like extract that water instead, right? So it's basically they end up in this rat race to consume the resource itself. So farmers have no choice but to extract the resource and forgo the opportunities from leaving that the water in the ground or in the aquifer as a stock that can be leveraged upon in the future. All right. So what do we do about it? Well, before we get to kind of some sort of policy interventions, I think it's important to kind of think about our definitions of sustainability. Well, sustainability itself, I feel, is a very normative concept. There's different sort of definitions and criteria that one can use to kind of think about what sustainability is. Often, if you speak to ecologists, they use something called the strong sustainability criteria, where they feel like when access to natural capital or environmental goods and services that we have in the present, we want to ensure that future generations have access to the same amount or even greater amount of natural capital or environmental goods and services. Whereas economists, on the other hand, tend to think about substitutability between natural capital and physical capital. So the idea is that in the present, you might consume environmental goods and services and natural capital, but as long as you're consuming this, but also replacing that with enough physical capital and leaving future generations with equal or greater consumption and production opportunities, that offers a good quid pro quo. So depending on where you lie on the spectrum, on what you feel is your sort of normative definition of sustainability, you can think about that effectively determines how you think about sort of managing the resource going forward. So in the end, it's basically kind of a trade-off between how much do we think natural capital is, how much of it can we substitute with physical capital, leaving future generations with equal consumption and production opportunities. All right. So from a purely kind of like economic, sort of orthodox economic perspective, using the weak criteria, the way to kind of visualize or sort of think about managing groundwater as opposed to leaving it as an open access resource comes under what we call optimal management. So optimal management assumes that farmers internalize without any intervention. We know that this is an open access resource. There's a rat race. Farmers are going to go and sort of like compete for extraction of the resource, right? But if you make farmers internalize that externality that they're enforcing on future generations, remember the fact that farmers are not leaving the resource in the ground because they feel somebody else will come and take it. So how do we get them to leave that resource in the ground, right? So that is effectively what we mean by farmers internalizing that temporal externality, that they realize that if we leave this resource in the ground, future generations will come and actually get some sort of benefit out of consumption of this resource. So, so optimal management effectively takes that into account to get farmers to internalize that cost that they bear on future generations. And in more technical economic terms, what we mean is that farmers are effectively there's a social, well, farmers themselves are not going to take these decisions. There has to be what we call a benevolent social planner. Now, this could be a state, it could be markets, but think about this as some sort of an outside agent that kind of is thinking about the welfare of the entire society, including farmers, and their objective in this sense is to maximize the discounted net returns over a long-term horizon. Yeah. All right, so here's an example from using data from SIN. This is part of work that I did during my PhD, where we're showing what happens to the aquifer in SIN over a period of 100 years under the status quo. If you assuming that water is a open access resource, which it is, what happens to net benefits from irrigation? What happens to the water table level? What happens to extractions over time? So in this under the status quo, what we demonstrate is that over a long-term horizon, the water table level falls by over close to 50 meters in 40 to 50 years. But if the resource was managed optimally, where farmers are actually forced to internalize the cost that they enforce on future generations, then what demonstrate is that, water table level is going to go down because there is benefit of extracting the resource in the present. And it's okay as long as, taking the resource out is being replaced with consumption and production possibilities. But the fact that farmers now have an incentive because they're being forced to internalize that externality, the extractions actually fall. So as long as extractions are going down and recharge is still less than the extractions, the recharge of the aquifer, the water table level falls, but not as dramatically as it does under open access. So net benefits as a result, because there's more stock of the groundwater in the aquifer. So there's more of the resource there. So, and it's now, because the water table level is higher, it's less costly to take that water out. Hence, net benefits from agriculture actually go up over time if water is managed in this optimal way. All right. So optimal management is basically sort of like an exercise, right? Because, without any institutional arrangement, groundwater is going to be treated as an open access resource. We want to, so the optimal management is a objective of a benevolent social planner. So if the benevolent social planner basically figures out that this is how the resource needs to be managed because it leads to greater benefits for society, then what are the policy instruments that we can leverage to get us from that open access equilibrium to the optimal equilibrium? Well, there are three kind of basic instruments that we can leverage. One of them, the first one is quotas, right? So you can think about groundwater quotas as as a restriction. So these are, in each period, you've done the benevolent social planner has done the calculations, figures out that this is what the optimal extraction should look like each year, and then it restricts and caps the emissions or the extractions at those levels in each period, right? And farmers are not allowed to exceed those extractions. So it's kind of like an official mandate on how much groundwater can be extracted. But in reality, enforcing quotas, now we can consider a basin with sort of millions of farmers, right, who are dependent on the resource and a very weak state. In practice, enforcing quotas is very difficult. And this example also assumes all the farmers are identical, but in reality, farmers are very heterogeneous, right? There's all kinds of farmers, they produce different kinds of crops, they have different sort of farm sizes, they have different kinds of access to technologies, etc. So there's a bunch of heterogeneity across farmers, and the amount of water that they need to use also differs. So for the benevolent social planner to figure out what an optimal efficient level of groundwater quota is for each farmer entails a lot of information burden. And so it's prohibitively costly. It's like impossible for like any, you can have the most powerful state in the world. You can even think about like a state like China, where the state is just, incredibly robust. But, getting that information to really figure out what those optimal quotas look like is incredibly difficult. So in the end, when in settings where quotas are used, often those quotas tend to be equal across farmers, but that leads to kind of inefficiencies because certain farmers need water more than others, and some need it less than others. All right, so if quotas are difficult to manage in the sense that, on paper they seem efficient and optimal, but they're in practice it's difficult to implement them, then what are sort of more cost-effective ways of getting farmers to get to this optimal equilibrium? Well, one way is to start charging them, right? So if we know that farmers need to internalize the cost of the resource, then this is not the cost of taking the water out of the ground. This is the cost that they enforce on future generations for extracting that resource in the present. So somehow we want to make farmers account for the cost that they're enforcing on those future generations, right? So you can price them, you can start charging them for that externality. So effectively then, you basically install meters, you measure how much water is being extracted per farmer, per farm, and you start billing them for that water, right? So in that exercise, in that example that I showed you for Sindh, we do that where we actually come up with an optimal charge over time, and we show that this is over time, this is the price that you need to charge farmers to get them to move from the open access resource equilibrium to the optimal equilibrium. Just a caveat here that this also kind of assumes that you need like a regulatory body or a water utility that effectively is managing how this charge is implemented. So they need to kind of, monitor extractions and then sort of bill farmers or users for the amount of resource that they're extracting. Another point to note here is that the charge itself can also be seen as a transfer payment, right? Like farmers are actually paying for the right to use this resource, but then you can reinvest. So this is, you can think about this as a tax. Although, we don't like to call it that, but people tend to be kind of averse to the term tax. But, this is a transfer payment from farmers to society, but this can be then reinvested back to farmers in the form of, capital expenditures or investments, or you can think about it as, investments in technologies. So, there's sort of all these innovative ways of thinking about how do we transfer, even though farmers are paying for the resource, how do we kind of transfer this payment back to farmers in a way that doesn't incentivize greater extractions? And finally, this is a more market-oriented kind of instrument, so cap and trade. So instead of having a regulatory body or utilities sort of charging farmers for their per unit use or a volumetric charge on the amount of water that they're consuming, you cap. So this is kind of like a combination between like a combination between a quota but so you basically cap emissions, but then you create this flexibility where you allow farmers to kind of start trading their quotas on a permit market. And what that does is that it basically kind of leverages the incentives inherent within the market system to move permits from those who really need them to those who don't really need them, right? So farmers who really are looking for like groundwater, they can go on these markets and kind of like buy groundwater permits from farmers who really have excess amount of groundwater, hence excess amount of permits, and are willing to sell them. And we can talk more about sort of the details of each of these policy instruments in the Q&A. And before I conclude, just a sort of like parting note on how, so a lot of conversations around groundwater, especially from economists, tend to focus on or especially the sort of conversations that we see in Pakistan tend to focus on the agriculture sector. But I think that the benefits from like optimally managing groundwater is just a lower bar on water itself. I think there's far greater kind of benefits that we can think about just from the fact that the Indus Basin was sort of a breeding ground for all kinds of cultures and societies. And any kind of like sort of depletion of groundwater or any kind of sort of water body also implies some sort of a cost on this development of cultures in the region. And it's not just cultures, but also sort of natural capital like estuaries and watersheds and deltas. So the ag benefits are just a lower bound. And if we actually take into account these larger kind of like environmental and sort of cultural benefits of managing the resource, I think we can even come up with a far greater sort of benefits or far greater figures for the benefits that we can gain from actually conserving the resource. And on that note, I shall conclude. Thanks.
Hello everyone, and thank you all for being here. I'm going to be talking about public goods, climate change and livelihood diversification. The question that I'm going to be asking all of us to think about for the next 20 minutes is there's generally a lack of programmatic provisioning or management of public goods. I'm going to show you evidence for that in the case of both urban and rural areas. For urban areas, I'll be talking more so about provisioning. For rural areas, I give you an example from one of my papers where I talk about management. And in the face of this sort of absence, what is happening to poor households as pressures stemming from climate change are rising? And can we use technology to help mitigate some of these pressures? And I'm really going to be thinking about livelihood diversification in this. And the reason why I'm posing this question is actually I've been thinking about this for some time. There's a lot of work that I've done in this space. I'm going to be sharing the work that I feel is relevant to answering this question. And then towards the end, I'm going to be brainstorming a little bit with all of you about future directions that I'm going to be taking. So I'm going to be thinking about low-income households, both in rural and urban areas. I'm going to be, like I said, talking about climate-induced effects here. I'll present some evidence to you both in terms of extreme heat as well as natural disasters. I'm categorically going to be looking at the case of drought and extending that, and we can extend that to other natural disasters as well. So some of the ideas for the work that I'm going to be sort of pointing us towards is actually coming post the 2022 floods. And I want to think through both the short-term coping mechanisms that households could potentially adopt as well as long-term livelihood diversification that households can do with a special focus on women. I work on women and labor market. In more recent years, I have been working a lot more on the intersection of technology with the labor market and how women can leverage technology. And in all of this, I continue to work on public goods provisioning in urban and rural areas. So I'm going to draw on all of that today, and hopefully there'll be some coherence to what I say. I'm going to sort of tell you a story, and then from that, I'm going to point us towards the idea of digital spaces. So what we know from the work that has been done in Pakistan, from my own work, I know that public goods remain a major concern. There is poor access to public goods. Even when there is access to public goods, it's unequal. Marginalized groups face a lot of issues. There's heightened vulnerability of these marginalized groups, particularly during times of scarcity. And that maybe digital space then becomes a viable option, an alternative means, particularly for the group that I'm specifically interested in, which is women. And I'm going to show you data on this. There is two types of data I'm going to be sharing with you today. There's a lot of primary data that I've gathered in the last 12 years. I'm not showing you all of that data. I'm going to be showing some specific pieces that I have worked on. One is these quantitative surveys that I did here in Lahore. We went to 12 slums in central and peripheral areas. These were randomly drawn from the entire list of surveys that the Kachi Abadi Directorate gave to us. We did mapping of these surveys. We looked at public goods provisioning in these surveys. I talked to households about issues of gas, water, electricity, their load sharing in that. And then we also talked to households about how they've gotten access to public goods. What are the means through which they gain access to different types of public goods. I'm not going to show you all of those results, but some of those to give you some idea of what's going on in these slums. Then I've done in-depth interviews. So there's some Two of my pieces are quantitative work, then there's a lot of qualitative work that I've been doing as well. I've done about 300 in-depth interviews with women across Pakistan in the last 3 years. A lot of these interviews actually have to do with their use of digital technologies, their access to labor markets, how technology is easing access in some cases, how it may be making access more harder in other cases, what are the issues that they face when it comes to accessing technology. And I've also done focus group discussions with some with these women, some with other women. Some were women who were HomeNet affiliates from these focus groups. In addition to these 300 surveys, which were in-depth interviews, I also did quantitative surveys with about 40 women drawn from these focus groups. And these focus groups discussions really highlighted to me that in the face of real issues as far as earning was concerned. So here we talked to women who were earning as little as 5 cents per trouser that they were stitching. In the face of all of those issues, they would still be talking about public goods and how having lack of access to public goods was making their life that much harder. And then I have done key informant interviews with government officials, activists, advocates, women rights groups, etc. So that's the primary data that I'm going to be drawing on in my presentation. In addition to that, there's some secondary data that I've used. There is the Pakistan Panel Household Survey. There are 4 rounds of it. I have used the 2001 round, which coincided with one of the worst droughts in Pakistan history, to really show you how scarcity exacerbates effects for certain classes of households. So let's start with public goods access. Public goods access, there's a lot of variation in public goods access when you consider even urban areas. So this is just central slums versus peripheral slums. And there's 2 types of public goods that I'm showing here, drains and paved streets. The reason why I've chosen these 2 public goods is because it's the households that highlighted to us how important these public goods are for them. Households that didn't have access to these 2 public goods wanted access to them. Even the households that did have access to them, if there were any issues with the road within the abadi or the drains within the abadi, that's the issue that they highlighted for us. And this is just within Lahore, the kind of difference that you're seeing. You're seeing nearly a 40-point difference, a 40 percentage point difference across peripheral and central slums. And I've looked at rural versus urban data as well, and the difference becomes even starker there. Now, when it came to trying to figure out how households got access to these public goods, the story is really interesting. The access is very much around elections. So around elections, they start seeing that these households will start seeing an upsurge in people coming into their slums, people giving them access to drains and paved streets. And this access was coming from politicians' discretionary funds. So what struck us when we did this work was that there was really no programmatic provisioning. It is not need-based. If there's a household which is able to have that connection to a politician and get them to pave their street, they would get that street right in front of their household. It's not even that they'd get it for that whole abadi. It could be really very targeted, this kind of provisioning. And no surprise, wealthy households, the analysis that we've done shows that wealthy households are more likely to receive these public goods. The lower your social class, and here we looked at their biradri. So if you belong to a lower biradri, you were less likely to receive these public goods. Now, we talked to 670 households. That's the total sample of what we've done in the urban slums. And this is the result from those urban slums. And these are the main findings from the regression analysis that we've done. But these are echoed in my qualitative research as well. So in the FGDs that I've done, and I've done a lot of FGDs with informal workers, they also said that public goods issues trump all other issues, including the wages that they're getting, including issues of exploitation that they may be facing from middlemen, etc. And they named all public goods. So that's aside from the streets or the sewage that these households have access to. They talked about education, they talked about issues as far as the hospital is concerned, they talked about issues as far as transport is concerned. They linked issues in these public goods provisioning to productivity, to income earning capacity, to their inability to really see better lives for their children. So I hope I've convinced you that public goods access is not good as far as these households is concerned. I just want to give you an example of transport. And the reason why this is really relevant for me, one, as somebody who looks at earnings, it was really stark for me that women were walking primarily when it came to getting access, and these are low-income women coming from low-income households. In order to get access to earning opportunities, they're primarily walking to their place of work, and then they would say that, look, it's too hot, there is no proper pathway for us, we can't walk to multiple households. And that would really reduce the kind of income that they were earning. So in today's, like literally today or yesterday or the day tomorrow, these women are going to be unable to walk to their place of work because the heat is just so high. So shade becomes a commodity that we really need to be thinking about. I mean, I don't want to call it commodities. Shade becomes a service that you really want to think about as far as these kind of places are concerned. Even when they have access, so I'm going to come to the second part of my presentation now. Even when households have access to public goods, the quality is compromised, the supply is compromised. During times of stress, marginalized communities see heightened vulnerability. I'll give you an example from the slums. So they may have access to sewage, but during rainfall, because the sewage would, the underground drains would get clogged with plastic bags, they would see that sewage overflow. So how much that public good works or how well that works, how functional it is, remains a question mark. I want to talk about rural households in the context of management of public resources. And this is some work that I've done using the Pakistan Panel Household Survey. And this was, like I said, 2001 round, where there had been one of the worst reported or worst recorded incidents of droughts in the country. Households, I looked at standardized crop yield. This is Punjab and Sindh, and what we saw was the standardized crop yield was much lower for households that were living in villages which were worst hit by droughts. Standardized crop yield tended to be lower for less wealthy households, for less educated households, for households that were along the tail of the canal. Just echoing some of what Sanval said earlier, if they're at the tail of the canal, the water that comes to them is that much lower in quantity. They didn't see that high yields for themselves. What mitigated these negative effects for them were if they were using mixed irrigation and if there was non-farm income available to the household. What really I was interested in was what happens if there's other forms of heterogeneity. Now, one of the things that I'm interested in is Biradari effects or class effects, but for this particular paper, what I looked at was language. So there's a lot of work. So either you can look at, so if you look at ethnically diverse communities, you generally tend to see that cooperation within those communities tends to be a little bit more compromised. So I used linguistic fractionalization as a means to look at heterogeneity within that particular community. And villages which were more linguistically heterogeneous saw households harder hit. So here's a graph from it. There was a significant difference in how worse these households were hit if they were living in a heterogeneous village. And there's a lot of work on this within the literature, and what the literature shows us is that when there's high levels of fractionalization as far as linguistic composition is concerned or Biradari composition is concerned, there's a lot lower cooperation. So in that cases, common pool resources, your groundwater, your canal water, they all become that much more harder to manage. So even if you have a system in place, even if you have, let's say you're able to manage your groundwater fairly well under usual circumstances, because either through government intervention or through community action, you've been able to come up with a nice robust set of social norms. All of that tends to go on the wayside anytime communities come under higher stress, which was the case when it came to this drought. Now, what I've been thinking about is this non-farm income. So when you're under stress and you know that your community is going to be harder for you to manage that public resource, or you don't have access to a public resource to begin with, you don't have access to that kind of income that you would like, what do you do in order to mitigate the effects on yourself? And what I wanted to focus on was this non-farm income for rural households. How do we get them to diversify beyond the farm? And how do we get their women more involved as far as earning within the household is concerned? So is tech the answer? Now, the reason why I came to this was because actually 2 or maybe 3 years ago, there was this really nice and really interesting story in Dawn's EOS, which was about this NGO working in Sindh that has been providing digital training to women who are doing livestock rearing. And through that digital training, what they did for these women was that they put them on online platforms, and these women then bypassed the intermediary and started selling their cattle themselves. They put the pictures on Facebook and other marketplaces, and they got to earn significant amounts of money. So here's a fairly low income setup where with a little bit of an intervention, we are able to see livelihood diversification and some improvements in lifestyle. And that's what I've been working on with my co-PI as far as improving women's earning opportunities in Pakistan is concerned. We've done many surveys with across occupations. We've talked to factory workers, home-based workers, domestic workers, business owners. We've talked to the advocates who are working with all of these women in these various areas. We've talked to this. There is definitely a Punjab bias in our data set, but we've done interviews in Quetta, we've done interviews in Chang, we've done, Chang is still the Punjab bias, we've done interviews in Karachi as well. Some of these interviews have been on telephone, most of these interviews have been online. And what we're finding is that there are some benefits of providing that tech space for women. There are opportunities that women are able to avail. They are able to diversify their income. They're able to switch jobs, go from more low-paying jobs or jobs where they see harassment to higher-paying jobs. They are able to tap into marketing and networking. They're able to upskill. Their safety and mobility becomes better. The upskilling is really interesting because they're upskilling in ways that we may not think about. They're using YouTube videos. They're using TikTok videos to learn lots of interesting skills. They're using apps in manners in which we don't necessarily think about. So they're able to do voice search on YouTube that my co-PI, who's a technologist, didn't know was possible. They're using WhatsApp quite effectively. They're using the WhatsApp image very effectively. So, and these are low literate women, by the way. What was also really interesting for us was that the reality of Pakistan is that the physical space is quite hostile. The digital space is also quite hostile. I'll add that caveat. But in this, when you're faced with a hostile physical space, the digital space perhaps allows these women slightly more freedom. If they're able to tap into this online market space, it allows them to work from home. It allows them to escape harassment, which they face quite regularly when they are walking to and from work. And it reduces their dependence on male family members. A lot of the women that we talk to, particularly the factory workers, depend on their male family members to actually commute to and from work. They depend on their male family members also in terms of the jobs, the kinds of jobs that they can work at. So it reduces that dependence. So can we use digital spaces in the way that I highlighted, the example that I gave of the livestock women to reduce vulnerabilities to climate change effects? I mean, if we can really tap in, we can allow the women who live in these households but are going to see the effects of climate change, if we can allow them or we can give them access to these digital spaces, it actually might allow that household to diversify into greater amounts of non-farm income. There are issues, there are caveats. Like I said, the digital space is not all benign. There are issues there. There is, of course, the issue of financial constraint as well. Most of the women that we talked to did not own their own. So 40% did not have their own mobile phone. The GMSA gives us similar statistics as far as Pakistan is concerned. There's a big gap, there's a big gender gap in mobile phone ownership, in access to digital networks and access to data networks. And even when women have access, they're very closely monitored. So just like their physical mobility is monitored, their digital mobility is also monitored. There's not a lot of supporting infrastructure as far as the digital space is concerned. We all know about issues of signals. We all know issues of connectivity. Our internet tends to be switched off at random points in time in the country. But one of the biggest issues is actually electricity outages. So this is data from slums, and we know that our urban localities actually have lower load shedding than our rural localities have. I mean, on the weekend, I was looking at numbers of average load shedding. Karachi is seeing 16 to 18 hours of load shedding these days. There's some rural parts of the country, which are seeing 18 to 22 hours of load shedding. So what I've said before about digital spaces, it's all great, but if you don't have electricity, how are you going to go online? This is just to highlight to you just the difference in load shedding within Lahore. So within Lahore, I went to, like I said, went to central slums and peripheral slums. And what I did was I divided my slums into those that are located close to influential areas. So any slum that is close to GOR or to packages, I categorize that as an influential slum versus in non-influential ones are not close to any of these sort of gated communities or industrial areas. Or rather, I should say they don't share a grid with these sort of more influential areas. And there's a big difference, a significant difference, an 7-hour difference, nearly 8-hour difference in the kind of load shedding they're seeing. And when they have that load shedding, what do? There's a significant number of households, more than nearly 70% of households, who are saying we don't do anything. We just wait and we just plan accordingly. We just plan our day around the load shedding hours. But that's if you know when the electricity outage is going to be. So yes, we think that digital spaces might actually be really interesting as means for households to diversify income in rural areas, in urban areas where there's lack of public goods and women don't have access to markets, for example. Perhaps they can go online and get that access instead. So we are finding evidence that women are able to use these digital spaces quite effectively to supplement the income, to the extent that sometimes they turn around and tell their husbands, you don't need to go out in the heat. I earn enough for everyone. But what I think what needs to be done is that there's just not enough support. And we don't necessarily believe in people coming in and telling women what to do and how they should be navigating these spaces. What we actually want to do is create these groups for women where we connect the women to their own network and the women troubleshoot with each other. Because like I said earlier, the workarounds that these women have come up with on their own are not workarounds that we have thought of sitting at LUMS. So what we'd ideally like to do is create these groups, work with the women to really think about the constraints that they're facing, design around these constraints, make it possible for them to connect with each other and really troubleshoot problems on their own. And what I will recommend is, we definitely need to have more infrastructure in place as far as electricity is concerned and mobiles and data is concerned. And one way to think out of the box is maybe think about community spaces, not just think about data within each home, but data within a community space where perhaps women